In today's video, I would like to introduce a very nice problem. It's coming from the Bulgarian mathematical Olympiad. Here is the following setup. For all x and y as a natural number, satisfy this following equation. We have y squared equals x to the 5 minus number 4. Okay, the question unsatisfying. Okay, which means does this equation have solution or no? Okay, so you guys, you can give the hands to this problem pre-get to a solution. Go ahead, pause this video when we come back to see the solution. Okay, so we have different exponents. It seems not convenient exponent which you can factor out, which you can put together with other term in order to make factorization clear here. Okay, so there is some tricks you can apply in order to factor out this one. So I'm going to use two methods here. So the first method, I'm going to use the factorization. The second method, I'm going to use the GCD. Okay, now let's get started. So it's more clear here. This expression y squared, which equals x to the 5th minus 4, I'm going to replace minus 4 with 32 minus 36. Okay, I get x to the 5th, which equals plus 32 minus 36. It's more clear. Okay, I get the following expression. I get y squared plus 6 squared, which equals x to the 5th plus 2 to the 5th. Now it's more clear here. Two terms, both of them are having the same exponents, so it's more clear. We are going to factor out that on the form of the product. I get x plus 2 factor x to the 4th minus 2 times x cubed plus 4 is multiplied by x squared minus 8x plus 16. Okay, so let's name this one as a capital A. So now if you take a look at the left hand side of this equation, this one we have a plus sign here, but we have the exponent is even. So this one you cannot factor out this one in integer numbers, so you cannot have the product here, which means this one was multiplied by number 1. Okay, which means the other term of the right hand side of this equation of the product is going to take number 1. Okay, but this one is strictly superior than number 1. It is not going to take number 1. Also, I'm going to prove this one is strictly superior than number 1. Okay, also I'm going to show this one is bigger than number 1. Okay, or I'm going to take this one minus number 1 is strictly superior than 0. So let's do that. So I get capital A minus number 1 must be strictly superior than 0. So I'm going to show this one. For x equals 1, I'm going to show also x equals 1. This one is strictly superior than 0. Let's put it also as a f as a function. So I get f of x equals x. Okay, so I'm going to calculate the output of number 1. Is going to give us 1 minus 2 plus 4 minus 8 plus 16. This one is going to give us 11, which is strictly superior than 0. Okay, so now I'm going to make the comparison when I have x is super equal to 2. So for all x is super equal to 2, so I'm going to factor out this one, x to the 4th minus 2x cubed plus 4x squared minus 8x plus 16. So this one is super equal to 0 because we get x super equal to 2. This one is strictly superior than number 1. This one is strictly superior than 0. Also this plus 15, which is strictly superior than 0. Okay, now we have shown this one is supposed to take number 1 because of this one, because this one was multiplied by number 1, which this one is going to take number 1, but it wasn't, which means we have a contradict this one, which means we have no solution for this equation. Let's move on to the second method. Now we are going to, in the second method I'm going to go in the second method I'm going through the GCD. So let's set GCD of x plus 2 and capital A. So what's the GCD of this one? So how are we gonna calculate this? So the nice trick here, we need to reduce this expression to the smallest value possible, okay? By adding and subtracting by adding or subtracting the multiple of x plus 2 here, in order to reduce this expression to know what's the value of GCD, okay? So let's work just on the capital A. We don't care about this one. They will have the same GCD at the end, okay? So for the capital A, which equals x to the fourth minus 2x cubed plus 4x squared minus 8x plus 16. So first step, I'm going to get rid of the x to the fourth. How am I gonna do that? I'm going to subtract the multiple of x plus 2, which I'm going to put minus x cubed factor x plus 2. So the GCD is not going to be changed if I'm adding the multiple of this one, okay? Or subtracting. So it's clearly x to the fourth will be cancelled out with this one. So I will be left with here capital A equals minus 2x cubed. With this minus 2x cubed becomes 4. Becomes 4x cubed plus 4x squared minus 8x plus 16. So I keep doing the same thing here. So also I'm going to cancel out this one by adding the multiple of x plus 2. So it's more simple. I get 4x squared factor x plus 2. So also this one will be cancelled out with this one. So I will be left with capital A equals 4x squared. With this 4x, I get 4x squared plus 8x squared, which is 12x squared minus 8x plus 16. So I keep doing the same thing. This time I'm going to get rid of this one. So by subtracting the multiple of x plus 2. So I get minus 12x factor x plus 2. Also this one will be cancelled out with this one. I will be left with following. I will be left with minus 8x minus 24x, which is minus 32x plus 16. This time I'm going to add plus 64 minus 64. Then taking minus 32 as a common factor for this one, and put this one separately, which is giving us 80. So I get the following. I get capital A, which equals minus 32 factor x plus 2 plus 80. Okay, so this time I'm going to add plus 32 x plus 2 because I'm adding the multiple of x plus 2. So this one, it's clearly is going to cancel out with this one. I will be left with 80. Now we found that GCD equals 80. If equals 80, at the same time 80 equals 2 to the fourth is multiplied by 5. Okay, so both terms, they are sharing number 5 or 2 or 4 or 8 or 16 or 80. Okay, you are going to check whatever GCD works for you. Just check the one is going to give us a contradiction. Okay, so the convenient one, which I'm going to work with, 16. Okay, GCD, I'm going to work with 16. Now let's get rid of this one and move on to the next step. So since we have 16 as a common divisor here, which means x plus 2 is going to take number 16 is multiplied by k, where is a k is a some natural number. Okay, so we don't care about k, what it is. So now I'm going to extract x from here. So I get x equals 16k minus number 2. Okay, now let's take this one and replace it into the original equation. So I get y squared, which equals x to the 50, is going to replace with 16k minus 2 all is raised to the fifth minus number 4. Now I'm going to reduce this equation to the mod 16. Is a congruent. This one will be 0. I will be left with minus 2 to the fifth minus 4, which is a congruent. This one is going to give us minus 36, because this minus 2 to the fifth becomes minus 32 plus minus 4, which is minus 36. Minus 36 is a congruent to minus 4 mod 16. Now I get a reminder minus 4, because we know 16 divide 36, keeping reminder number 4. Okay, so what to do, I'm going to add number 16 on both sides. So I will have here is a congruent to 12 mod 16. Okay, so we get y square is a congruent to 12 mod 16. Well, what to do, I'm going to go through the chart to see what's the possible reminders when you reduce this one to the mod 16. Okay, so let's ignore the value of 0 because we are dealing with the natural numbers, so we'll have the same thing, 0 here. So let's start with number 1. I get the following reminders: 1, I get 4, I get 9, I get 16, which is 0. Okay, I get 25, the remainder is 9, 36 remainder is 4, 49 remainder is number 1, 64 is a remainder 0, 81 is a remainder number 1, 10, which is 100, I will have 96 is divisible by 16, I get a remainder number 4. Okay, so if you take a look at here, we have the kind of pattern here, which means y square is belongs to this set, 0 and 1 and 4 and 9 only. Okay, so but we have an absence of 12 as a remainder here in this statement. This is, it's clearly it's a contradiction. Okay, it's impossible. We have proven by using two methods that this equation doesn't accept any solution. Okay, so by the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. We'll see you next video. Bye.